This is again a simple video on information coding. Which can be used, initially I look at a technique which can be used both for data compression as well as for error detection and correction. So it's a very simple technique. Now again our objective is to map a number which is say a value k which is less than m equal to 2 power l dash, to losslessly map it as much as possible to a value v which is less than s equal to 2 power l, where l dash is much larger than l by a reasonable factor. Now probably an immediate thought which occurs to us is to determine r such that r plus 1 plus r square plus r cube plus r power l dash is equal to 2 power l. Okay. Now we can so this is nothing but 1 plus r power l dash minus 1 equal to 2 power l. This is nothing but r into 1 into r power l dash minus 1 by r minus 1 is equal to 2 power l. In other words, we have r power l dash minus 1 is equal to 2 power l times r minus 1. Okay, so r power l dash minus 2 power l times r plus 2 power l minus 1 will be equal to 0. Okay. Now we know r will lie between 1 less than r less than 2. So there are different ways of doing this. You can either use approximations, right? For this we might take one of them as ri, ith approximation. The other one, occurrence of r as ri plus 1. Express ri plus 1 as a formula for ri. Or take this as ri plus 1, take this as ri, and express ri plus 1 in terms of ri. Start off with an initial value. R will be very close to 2 power L by L dash. Okay. You can start off with this as the initial value, or the other way is you can express R as 1 plus x, where 0 less than x less than 1. You can use 1 plus x power L dash minus 2 per L times 1 plus x plus 2 power L minus 1 equal to 0. You can use binomial expansion for this. Up to 3 terms or 4 terms it will take. Some of them will get cancelled and you will be able to solve for x to a very reasonable degree. For this you have to take a binomial expansion. You can write this as 1 plus L dash C1 x power L dash minus 1 plus L dash C2 x power L dash minus 2. Okay. And so on. Or you can take the other way around and solve it for that. Okay. You will be, in general, equations of this form keep arriving, where of the form r power n something minus c times r plus c minus 1 equal to 0 occurs a few more times. So you can determine r this way. So now the only problem is, since 1 less than r less than 2, when we start off with the, if we were to add r power I to the value, hash value or value that we are computing for the binary this thing, it will not preserve the order because r is less than 2. Some of the values of the lower sum, 1 plus r up to r power I minus 1, sum of all of these values will be greater than r power I. So it will not preserve the value. A simple solution which is very effective, which should be very effective, hence it can be used both as data compression as well as for error detection and correction, both as some kind of a signature checksum value only. Is this, if you have so you have 0, 1, 2 and so on up to the ith bit here, and so on up to the L dash minus 1th bit here. Okay. So you have some number here, 0, 1, 1, something, 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 1. Ith bit is 1, but it is the jth one, where j less than or equal to I. So now what happens is, it is the jth one. You do not add r power I alone, you add r power I plus j. Right? That means it is the jth one. That means before the ith bit, exactly j minus 1 i's have occurred. Now the largest possible value we having j minus 1 i's before the ith one are just all the ones preceding it. So let us see what happens here. You will have r power I minus 1 plus j minus 1 plus r power I minus 2 plus j minus 2 plus and so on, plus the last term will be I minus j minus 1 plus 1. Okay. This j minus 1 must be in bracket. Okay. So this will be the sum of the j1s. Okay. So this gives you, first term we can take out the least term in this, which is r power I minus j plus 2. We can see that this is a GP series whose ratio is r power r square. Okay. So this will be r power 2 times j minus 1 by r power 2 times j minus 1 by r square minus 1. This sum will be equal to, this I can afford to, if I ignore these ratios will pretty much be close. This will be equal to r power I minus j plus 2 into r power 2j minus 2. This will be nearly equal to r power I minus j plus 2 plus 2j minus 2, which is r power this will be r power 2 into j minus 1 here, because if we take the first term out, this will come up to, there are in all j minus 1 terms here, this should be j minus 1. So this will be 2 into j minus 1 minus 2. Okay. So this will be minus 4 here. This will be r power I plus j minus 2. Okay. I'll perform the derivation again one more time here above cleanly so that you can see. So we have to check r powers, find the sum of r power I minus 1 plus j minus 1 plus r power I minus 2 plus j minus 2 and so on up to r power I minus j minus 1 plus 1. So if you take the first term as a common factor out, you have r power I minus j plus 2 times r square is the thing, there are exactly j minus 2 terms. You will have r power 2 into by r square minus 1. Which should be equal to, and this should be equal to r power I minus j plus 2 into r power 2j minus 2 minus 2. This is equal to r power I plus j minus 2, which is less than r power I plus j. So you can use this. If the ith bit is the jth one where j less than y, you can add r power I plus j to the value, right? So the largest possible value that you can add will be must be such, the largest possible value you can add is must be r power 2 L dash, right? R power L 2 L dash roughly. R power 2 L dash nearly equal to 2 power L, or R is equal to 2 power L by 2 L dash, right? Another way to do it is, like I said before, 1 plus R plus and so on plus R power 2 into L dash minus 1 equal to 2 power L. You can solve this expression, right? Like we did for R in general, that you can solve it here. And determine a value of R, or you can use the initial approximation as this and try to determine the value of R which converges to this. So this way you can, it will preserve the order as well, and you will also get, if you are taking the, and there will be two parts for this code actually, an integer part and a fractional part. If the bit representation for the is of something of a floating point format consisting of a sign followed by mantissa or significant followed by exponent, need not be the standard available forms. You can use a slightly larger form if you want for really large thing. So this serves both for error detection as data compression and error detection correction in general of finding the checks. Generally simple solutions tends to be very, very effective.